Okay, our last chapter is going to be about factoring. So we're going to start by finding the greatest common factor. So first of all, let's just find out what it means to be a factor, right? Factors, whoops, let me get my pen. Factors are those things that are multiplied together. So for example, the factors of 6 are 2 and 3 and 1 and 6. Right? The factors of 12 are 6 and 2 and 3 and 4 and 12 and 1. Okay, so if we want to list all of the factors, for example, of 18, all of the factors of 18, I'll do it up here, okay, is 1, 2, 3. Now 4 doesn't go evenly into 18 or 5, but 6 does, and 9 and 18. The factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. Okay, so there's our factors of 18, factors of 24. If we're talking about common factors, right? Well, of course, 1 is a common factor. 2 is a common factor. 3 is a common factor. And 6 is a common factor. The greatest common factor of 18 and 24 is 6, right? It's the biggest one they have in common. Factors are also called divisors of a number, so we could be talking about the greatest common divisor, the biggest number that divides evenly into 18 and 24. So first of all, let's just practice finding our greatest common factor. Okay, so between 36 and 60, one thing I could do is what we just did and list all of those factors. Okay, or I could do my prime factorization for each one. Let's do 36, which is 6 times 6, and then each 6 is 2 times 3. Okay, our prime factorizations. That means this is 2 squared times 3 squared. If I did it for 60, 6 times 10, 2 times 3, and 2 times 5. So this is 2 squared times 3 times 5. So if I want the greatest common factor, I take anything they have in common, right? So they both have a 2 squared. I'm going to take that. And they both have at least 1 3. This one doesn't have a 3 squared. It only has 1 3. So all they have in common is that 1 3. You always take the one with the smallest exponent. So 4 times 3 is 12. 12 is the greatest common factor for 36 and 60. 12 goes into 36 evenly, 12 times 3, and 12 times 5 is 60. Okay, let's look at this. 18, 90, and 26. This time we've got 3 numbers. So 2 times 9, 3 times 3. So this one is 2 times 3 squared. Let's do 90. What do we got? 10 times 9. So 2 times 5 times 3 times 3. Okay, so 2 times 3 squared times 5. And 126. Okay, so maybe that's 2 times 63. And 63 is 9 times 7. And 9 is 3 times 3. Okay, so this is 2 times 3 squared times 7. Okay, now if I want what they have in common, oh look, they all have a 2. They all have 1 2. Okay, and they all have a 3 squared. They don't all have a 5 or a 7, so this is 2 times 9. 18 is the greatest common factor between 18, 90, and 126. All right, one more. 48, 61, and 72. So 48, 6 times 8. 6 is 2 times 3. 8 is 2 times 4. And 4 is 2 times 2. All right, so this is 1, 2, 3, 4. 2 to the 4th times 3. 61. Oh, 61. Does it have any factors? Let's think. It's not divisible by 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9 or 10. 61 is prime. So let's try 72. This is 9 times 8. And 3 times 3. 2 times 4. And 2 times 2. So this is 1, 2, 3 times 3 squared. Okay, look and see what they have in common. Because this only has a factor of 61, this thing doesn't have anything in common. If there's no other common factor, there's always a 1. Right? Okay, and we would call these relatively prime. Okay. So let's see how we're going to use this. Let's find the greatest common factor for each thing in the list. Okay, so 12 and 30. Now, I could find my prime factorizations if I'm not sure what it is, but also we might can tell that 6, right? A lot of times, most times for the numbers, unless they get kind of large, then I've got that method to fall back on of finding my prime factorizations. But if they're reasonable sized numbers, right, I might be able to tell that this is 6. Now, think about this. If I have variables, that means this one is x times x, and this one, because it's x to the 5th, looks like this. So if I'm looking for what they have in common, oh, they have one x in common, they have another x in common, and that's all. This one has more x's, but they don't both have more x's. So it's always the smallest exponent on the variable that's your common factor. So this, to find my common factor over here, x to the 5th, x to the, okay, they've all got x's, but it's the one with the smallest exponent, so it'd be x to the 4th. Y squared, hey, they don't all have a y, so x to the 4th is my common factor for these 4 different terms. Okay. So now instead of just finding the factor, so pay attention to what the instructions say. It actually says factor out the greatest common factor. Okay, so that means if I have a number like 10 and I want to write it as its factored form, it's 2 times 5, right? So after I factor the 2 out, then I've got to recognize, oh, that means the remaining factor is 10. So for this one, if we're factoring out the greatest common factor, here's my 2 terms. So I'm looking at what they have in common. Now notice, the previous slides, we just had commas between this. We didn't have polynomials. We just had individual terms, and it said, what's the common factor? But now, this is telling me to actually factor out the common factor from this polynomial. So if I look at 24 and 40, okay, I'm thinking, oh, I think the common factor of that is 4. And between an x to the 5th and an x cubed, it's always the one with the smallest exponent. Now, my next step after I factor out a common factor is put a parenthesis. Because remember, if we're changing to factored form, oh, it's going to be multiplying. So that's how we indicate multiplication. And then what's left in here is the remaining factor. So I can think of this a couple of ways. 24 divided by 4 leaves 6. X to the 5th divided by x cubed leaves an x squared. When you multiply it back, it's got to give you the exact same thing you get here. So another way we could say that, if I factor a 4 out, there's a factor of 6 left. If I factor out x cubed, I've got an x squared left. Now I've got a minus in the middle. Okay, 10. And the whole x cubed is already out there. Close your parenthesis. Okay, now I double check, just like if I was reducing a fraction. If I had the fraction 10/20 and I reduced it to 5/10, I would not be finished because it's not completely factored, right? We just got to keep checking. Same thing here, and I notice, hey, 4 was not the greatest common factor. Okay, so once we actually start factoring, I just have to make sure and check. If I miss getting the biggest one the first time, that's fine. Just double check and make sure there's not another factor. Oh, these are both divisible by 2. So now I can also bring a 2 out. And remember, everything's multiplication, so don't add it to this 4. I'm bringing another factor out, a 2. I already have 4x cubed there. Now, 6 divided by 2 leaves a 3. The variables I didn't change. And 10 divided by 2 leaves a 5. So finally, we have 8x cubed times 3x squared minus 5. That's considered factored. And I can always check my factoring. That's a great thing about factoring. I can always check it. If I multiply it back out, it better give me this thing right here. So this is 24x to the 5th minus 40x cubed. Is that what I started with? Yes. So there I have that thing factored. Okay, let's do it again. So over here I've got 3 terms. So I'm looking at the numbers first. Hey, they don't all have a number. So the only number I can factor out there is a 1. This has an x to the 6th, an x to the 4th, and x squared. They all have some x's. The greatest common factor is an x squared, right? These have more, but this one doesn't have any more than x squared. They all have some y's, and once again, the greatest common factor is y squared. Then put a parenthesis and put what's left when you divide this out. So the 4 is going to be left. X to the 4th, y squared. Let me move that over and give us some more room. All right. No number, but I can factor out an x squared and a y squared. Then you put your parentheses every time. As soon as you pull a factor out, your next step is put a parentheses. And then write what's left when you divide this out. So 4 divided by 1, the 4 stays the same. If I've got 2 x's out here and there was 6, that means there's 4 left in here, right? 4 y's, but I've pulled out 2. That means there's 2 left in there. Okay, the number stays the same because I didn't have a numerical common factor. X to the 4th, divide out x squared. Y cubed, you've got 2 of them out here, that leaves 1. Hey, this whole thing came out, so don't forget, if everything factored out, a common mistake is people say, oh, that's gone, I factored it out, and they close the parentheses. But if you divide something by itself, it leaves a 1, right? Not a 0. Also, it's got to be the same thing when you multiply it back out as what you started with. If I didn't have this 1 here, when I multiply this back out, I'd only have 2 terms. So that's important. Don't forget, if you factor the entire term out as the common factor, then it leaves a 1. Okay, same thing. Now, if you have a negative in your leading coefficient, you want that to be part of your factor. Even if there's not any other numeral that comes out, always factor out that negative. Okay, you don't want a negative in front. Now, I notice between the numbers 3, 15, and 6, oh, those are all divisible by 3. They all have some x's. What's the most number of x's that they all have? Well, that x squared. So now that I know what my common factor is, you put a parenthesis, next step, and then what's left over when you factor this out or divide it out from each term. So I've brought the negative 3 out, 2 of the x's, that means there's going to be 3 x's left inside. The negative has come out to the front, and the remaining factor of 15 from 3 is a 5. And there's going to be 1 x left right here because I factored out an x squared. Okay, positive 6 divided by negative 3 is negative 2. And the whole x squared got factored out. Now don't forget, you can always check your factoring by multiplying it back and see if you get what you started with. Okay, so that's factoring out the greatest common factor. Look at this. Here's my 2 terms, right? And this one we had 3 terms. So I looked at all 3 terms to see what they had in common. Whatever they had in common, I brought out as a common factor. So because this is in parentheses, that's one thing, right? So z to the 4th minus 3, look, they both have a z to the 4th minus 3. Hey, that z to the 4th minus 3, that's the common factor. So if I bring that out, it's got to stay in parentheses because we're treating that as a unit, z to the 4th minus 3, right? That's one thing. Keep it in parentheses. And after you write your common factor, your next step is put a parenthesis. Okay? Now, if I take this z to the 4th minus 3 out, if I divide it out, what's left right there is a w squared. And if I divide it out over here, there's a plus 5. Now notice, this is considered factored because I have 2 things now being only multiplied together. Right here, I have 3 things being only multiplied together. Yes, there's some plus and minuses in here, but this is one thing because I'm holding it in parentheses. So this negative 3 is being multiplied by the x squared, which is then being multiplied by all of this. If we were to leave off those parentheses on that z to the 4th minus 3, this is a different thing. In this, only the 3 gets multiplied, right? I would only multiply the 3 through here. On this one, I would have to multiply the z to the 4th and the negative 3. Totally different things. So it's really important to keep those parentheses around that common factor. And we're going to use this idea to help us factor some more. So we'll get some more practice at doing this. But right now, factoring out the greatest common factor. Okay. Now we're going to do something called factoring by grouping. So the first thing we do every single time, don't forget this, is look for that greatest common factor. So these don't all have a number. They don't all have an M and an N. This doesn't have a greatest common factor. So if you have 4 or more terms, we can do something called factoring by grouping, right? By grouping, where I'm just going to group this into smaller groups of terms and see if these have anything in common. Now I notice that, hey, these two do have an M in common, so I can factor that out. And that leaves a 5 plus N, plus sign, so no worries. These two have a 4 in common, and when I divide a 4 out of each of these terms, it leaves a 5 plus N. And now look, here's my 2 terms. Man, I'm not finished factoring yet because of this. Everything isn't being only multiplied, right? I know I have a plus sign here, but still that 5 and that N are both being multiplied by M. But this isn't, this is 2 separate things being added. Okay, so here's my 2 terms. Now this is actually what they have in common. So I'm going to factor out that 5 plus N, and it's got to stay in parentheses. Next step is add your parenthesis. And if I try to figure out what's left, when I factor this out, think about dividing this out. Oh, there's an M. And if I divide it out over here, or factor it out, there's a plus 4. Okay, let's check that. 5M plus 20 plus MN plus 4N. 5M plus 20 plus MN plus 4N. It's the same thing. So you can always check your factoring to see if you got it correct. All right, let's do the next one. Okay, let's see. Well, there's a 15 and there's a 4, so there's not a common number. They don't all have an X and a Y, so there's no common factor. Don't forget to check that first. So I'm going to factor it by grouping because there's 4 terms. So I'm going to group these together and these together. Now, if I just look right here, these both have a 2 and an X in common. So I'm going to factor out the 2X, and then you put parentheses. Okay, what's left here? 6X divided by 2X. Or when you factor 2X from 6X, there's a 3 left. Okay, when you factor 2X from 4XY, there's a 2Y left. Now, I've got a minus sign this time, so I've got to be careful. I know because of what happens when I'm factoring, I'm about to put a parenthesis right there because I'm going to factor something out and then I'm going to put a parenthesis, right? I'm going to factor out that 5 and I'm going to put a parenthesis. So that means if I've got a negative in front of a parenthesis, the signs in here change. This will be positive and that'll be positive now. Or you can think of it as you're factoring a negative 5 out. Right? If there's a negative in front, I always want it to come out. Okay, so negative 10 divided by negative 5 leaves positive 2y. Negative 15 divided by negative 5 leaves positive 3. Now, here's my 2 term. Remember, I'm not done factoring. That's not everything multiplied and multiplied only. This is 2 things being subtracted. So I want to see if they have anything in common. This is 3 plus 2y, and that's 2y plus 3. Do you think that's the same thing? It is. 2 plus 3, 3 plus 2, same thing. Addition is commutative. We've talked about that, right? So 2y plus 3, put your parenthesis because I've factored that out to the front, just like I brought this 2x out, brought this out, then put a parenthesis. Now, when that cancels, there's a 2x left there, and this one comes out to the front, there's a minus 5. And I could multiply it out and check it if I wanted, which is not a bad idea until you get really good at it. Okay. So 16, doesn't have a number, doesn't have an m, doesn't have a p. Don't forget to look for a greatest common factor first. So if it doesn't have a greatest common factor, I'm going to try to factor it by grouping. When I look at these two terms, what do they have in common? A 4 and an m squared. Put your parenthesis, so that leaves 4m minus 4m squared has come completely out, so that leaves a p squared. Got a minus sign, so be careful. I'm really factoring out a negative p, right? P is the only thing they have in common here. So if I take out negative p, this leaves 4m. And if I take out negative p, a negative negative is a positive, so there's going to be a negative here, and p squared. Okay, so here's my two terms separated by the plus or minus. Oh, look, they both have a 4m minus p squared. And you put your parenthesis, and what's left is 4m squared minus p. And now it's two things being multiplied together. Only multiply instead of four things being added and subtracted. Two things being multiplied. Okay, everything's got to be multiplied to be considered factored. Factors means everything's being multiplied. Okay, they don't all have a numeral, they don't all have an a or a z, so it's another factoring by grouping. Here, these two terms both have a 7z. Put your parenthesis after you pull out your common factor. What's left in this term would just be a z. What's left from this term would just be a 2. You got a minus, so be careful with your signs. These have an a in common, technically a negative a. So if I take out the negative a, there's a z. If I take out the negative a, there's a positive 2. Okay, now they both have z plus 2. And what's left? 7z minus a. Awesome. Okay, whoops. Let's try that one more time. Okay, 8 and 15, so there's not a common number, no a, no b. It's a factoring by grouping. Okay, these have a 2 in common. If I divide out or factor out a 2 from each of these terms, it leaves a 5a squared minus 6b. Plus sign this time, so no worries. These have an a in common. If I factor an a out, it leaves a 5 minus 8b. So here's my two terms. Is 5a squared minus 6b the same as 5 minus 8b? No. No. So that didn't work. So we might sometimes have to rearrange our terms, right, if it doesn't work. Okay, now also later, I don't think you'll have any in this section, but later sometimes there's things that won't factor, like the number 7. I can't factor that any further other than saying 1 times 7, right? Or 5 or 13. And so those are going to be prime. But before we decide it's prime, make sure we've exhausted our possibilities. Just because it doesn't work in one order doesn't mean it won't factor. So when I'm looking, okay, well, I noticed, let's put these together and then maybe these, because these both have a B, these both have an A. So I'm just going to rewrite it. 10A squared plus 15A minus 12B minus 8AB. And I'm going to try it again. All right, I'm going to try my factoring again. So these two and these two now. Now I can factor out a 5A. And that's going to leave 2A plus 3. Got a minus sign, so be careful. Now over here I can factor out a 4B. So I factored out, really, remember, negative 4B. So that's going to leave 3. Minus come out. 8 divided by 4 is 2 and the B. So plus 2A. Okay, and so my question is, here's my two individual terms that are separated by the plus or minus sign. Is 2A plus 3 and 3 plus 2A the same? Oh yeah, that is the same, right? So I can pull that out, 2A plus 3, and that leaves 5A minus 4B. Okay, factoring, looking for the greatest common factor, and then factoring by grouping. All right, you want to get real good at each section of factoring before we go on, because it's going to heavily build on each other. Okay, let me know.